Welcome to the Explainer. Okay, let's just dive right into this because right now there's an invisible trillion-dollar constraint capping the potential of literally every single frontier AI system we use today. Whether you're using ChatGPT, Claude, or Gemini, they all suffer from the exact same fundamental flaw. And solving it, well, it isn't just some abstract research milestone. It is an event that's going to completely rewrite the global AI economy. You know Christopher Nolan's movie Memento? The protagonist, Leonard, is brilliant in the moment, but he has severe amnesia. He can't form new memories. And honestly, that is the perfect diagnosis for our current frontier models. They are highly resourceful and observant while you're interacting with them, but they utterly lack the ability to compound that knowledge. They are brilliant within any single scene or prompt, but every experience they have remains completely external to that. The technical reason for this amnesia boils down to a hard, rigid boundary between training and deployment. See, in the AI world, models compress experience into their internal weights during their massive training phases. But the second they get deployed into the real world, that learning just stops. Completely. They become frozen amnesiacs. They start totally fresh with every single conversation. The minute you close that chat window, from the model's standpoint, it simply never happened. To put the sheer scale of this problem into perspective, futurist Thorsten Meyer estimates a staggering $150 billion with a B is spent globally every single year just to build workarounds for this memory limitation. That isn't the cost of the AI itself. That's a hidden tax enterprises are paying strictly because these models cannot retain what they're told. So, what does this memento tax actually buy us? Basically, it buys incredibly expensive, elaborate Polaroid and tattoo infrastructure. Think about it. We're using vector databases that can cost up to $50,000 a year for a single workload, massive compute just for embeddings, and incredibly complex retrieval logic. But at the end of the day, all of this is just scaffolding. It's a wildly intricate system desperately trying to compensate for a model's underlying inability to actually learn on its own. Researchers Albuquerque and Borenstein break this down beautifully into three learning layers. Layer 3 is that external context we just talked about, highly commoditized today. Layer 2 involves modular adapters, things like fine-tuning, which has basically become the enterprise standard. But Layer 1, updating the actual core model weights continuously during deployment, that is the holy grail. It is the uncracked frontier where the real magic, and frankly, the asymmetric economic advantage lies. Now, you might be thinking, wait a minute, what about those massive 1 million or 10 million token context windows we keep hearing about from Google and Anthropic? Doesn't that solve the memory issue? Well, not exactly. Brute forcing a larger context window absolutely does not equal true memory, because at the end of the day, a bigger filing cabinet is still just a filing cabinet. In fact, relying on massive context windows as a memory substitute falls apart for three very specific reasons. First off, a model's attention sharply degrades past roughly 500,000 tokens. It's just mental real estate the model can't effectively scan. Second, if you're running long, complex agentic workflows, those loops quickly fill up all that available space anyway. And third, cross-conversation persistence is still zero. An infinite context window doesn't change the fact that the AI still unlearns absolutely everything by your next Monday morning session. So why haven't the big labs shipped Layer 1 continual learning yet? Why is it so hard? Well, the main culprit is a terrifying failure mode called catastrophic forgetting. Without strict constraints, a neural network that updates itself on new data simply overwrites its old data. You could teach an AI groundbreaking new medical knowledge this afternoon, and those new updates might completely erase the complex legal documents it flawlessly memorized this morning. But wait, it actually gets scarier than just forgetting facts. There's also alignment drift. If a model updates its core weights based on live interactions, malicious users could repeatedly push it toward unsafe behavior. This creates a nightmare scenario known as jailbreak persistence, where an AI out in the wild permanently erodes its own safety guardrails simply by experiencing bad user prompts over time. And even if we solve the tech, there's a massive audit roadblock from a compliance standpoint. Heavily regulated industries, think healthcare or finance, they simply cannot legally procure or deploy a model whose core parameters and properties continuously drift every single Tuesday. They require a certified frozen baseline, which continual learning fundamentally breaks. Despite all these hurdles, make no mistake, the invisible thriller race to solve this is very much on behind closed doors. Thorsten Meyer actually mapped out the probabilities of who will cross this finish line first. Right now, it's basically a dead heat, with Anthropic and OpenAI running neck and neck at an estimated 25% probability, and Google DeepMind right on their heels at 20%.
Everyone brings a totally unique hand to this poker game. Anthropic has the world-class alignment and interpretability tools needed to monitor changing weights safely, but they face heavy capital constraints. OpenAI has an incredibly aggressive product velocity and a massive budget, but they face the tail risk of rushing an unsafe release. Meanwhile, Google DeepMind holds the deepest foundational research bench in the world, but historically, they've struggled to translate that into faster product velocity. We also absolutely cannot count out the dark horses, who are perfectly positioned to quickly integrate any breakthroughs. You've got Meta with its super aggressive open source channels, xAI with immense capital and federal distribution access, and major Chinese labs like DeepSeek pushing massive architectural innovations, like highly advanced mixture of experts routing that could pair perfectly with continual learning. When this breakthrough finally drops, let's call it day zero, it compresses everything. Suddenly, every CIO is going to realize their current static AI is completely obsolete. This is going to trigger a massive, highly accelerated 60-day enterprise migration wave, permanently shifting 20 to 30 points of enterprise market share in the first 12 months to whoever manages to ship this capability first. This rapid consolidation triggers what Myers strategically calls the Memento Singularity. It's this asymmetric runaway scenario where the winning lab's lead begins to compound exponentially. Because their AI is actively learning from every deployed interaction, it gets smarter at a speed that literally rewrites the entire AI economy. It moves so fast that rivals physically might not be able to catch up. So how exactly do we survive this tectonic shift? We need a playbook. Here is a 3-step action plan you can adopt today to make sure you aren't completely crushed by the memento tax when continual learning finally arrives. Rule number 1, do not get locked in. You must recognize that your current, highly expensive memory architecture is just temporary scaffolding. Treat it as transitional. Keep your vector database and retrieval contracts strictly under 24 months, and absolutely avoid proprietary lock-in for infrastructure that is going to be rendered totally obsolete by models that can just remember things on their own. Rule number 2, and honestly, this is absolutely vital if you're building an AI strategy right now, you need to start building what we call an experience corpus. Start stockpiling a massive database of your AI's attempted tasks, its observed outcomes, and any human corrections today. When a continual learning model finally drops, that captured data will be the exact premium fuel it needs to instantly learn the deep context of your business on day one. I love how researchers Abakirova and Bornstein summarize this whole transition. They note that we are about to cross the boundary where an AI's competence is no longer artificially bounded by the sheer amount of compute used to train it. Instead, its capability is going to be driven by its compounding time deployed out in the real world. We are shifting from pure amnesia to actual compounding experience. And really, that brings us to the core of why this matters so deeply. I want to leave you with this ultimate strategic question to think about. Are you prepared for the exact moment your AI stops being just a brilliant non-compounding tool that you operate and finally wakes up to compound its own competence? The race might be invisible right now, but the finish line changes absolutely everything. Thanks so much for joining me on this explainer, and I'll see you next time.